Okay, so this one says Larry also rides his bicycle along a straight road from home to school in 12 minutes. So he takes the same amount of time as Karen does. His velocity is given by the function W of t, where W of t is in miles per minute um, for the interval 0 to 12 minutes. Who lives closer to the house, Karen or Larry? Show the work that leads to your answer. Okay, so we have to figure out who lives closer to the house. In other words, who has less miles to travel, right? So what do we need to do? What do we need? How do we answer the question? How do I answer the question? How will I answer the question? In other words, I don't know the answer yet, but how will I know the answer to the question? When what? Yeah. What?
Finding out the displacement, the lower would technically be closer.
Kinda. So finding who travels farther. That's it. Yeah. Finding out who travels farther. Okay. Finding out who traveled farther, Larry or Karen. Karen traveled this much. Larry traveled this much. You're done. Who did? Okay. Karen, do we know how far she traveled? We know something about Karen, right? We've been answering the last 3 questions have been about Karen. So we know some things about Karen. So do we know how far that Karen traveled? Kind of a trick question. Actually, we don't know how much she traveled. What was 1.8? Isn't that what we're looking for?
Not exactly.
That's why I said it's kind of a trick question. She traveled 1.8 miles. We know that. We did that in part B, right?
But right now, what we're looking at is the distance from our house to the school.
How's that different?
How's that different?
Because she traveled 1.8 miles. She goes from school, from her house to school, right? And then in part B, we said she travels 1.8 miles. But that's not the right answer. That's the right answer for part B, but not the right answer for part D. Why? Because she returned back to her house. So part of that 1.8 is doubling back. So it's not going to be displacement because no one travels displacement because you travel along roads or paths or bike paths, right? Displacement means straight line distance, right? So it's going to be total distance still, but we have to subtract the part that she traveled backwards. So let's go to the graph. Where did we say that she started back home? We talked about this at the end of Friday. We talked about the graph. So at t equals 2, what does that signify?
She turned around, or she stopped.
Stopped and turned around. So where do we find? How do we find air? How do we find total distance? In case we forgot from Friday. How do we find total distance? Okay, so where do I start with area under the curve? Why 5?
That's the point where she starts the journey.
So 5 is where she starts her journey, right? We talked about this, right? 2 is where she turns around. 4 to 5 is where she's in the house getting what she needs to get. 5 is where she goes off. So we're not, so the question is kind of a trick question because it says from 0 to 12. Well, we don't really care what happened from 0 to 5 because it's like a do-over, right? It's like a do-over. She didn't actually start her journey until minute 5 because she went, came back, and then at minute 5, she came back or she started her journey. So this is the area we need to find for Karen. That'll tell us total distance from her house to school because after she left for the second time her house, she didn't do anything else. She went right to school. So we got to find area there. Okay, that's what we got to find for Karen. Karen total distance traveled. Okay, so find that right now. I'll give you a few minutes to find that.
Mr. Flores,
Mhm.
even if we did find displacement when you're adding up the two triangles from t equals 0 to t equals 4, those two would cancel out anyway. So.
Okay. So if I add area under the curve for Karen, it's 1.4 miles. So that's how far it is from her house to school. Okay. Based on the graph. Based on the graph starting at 5, because that's when she leaves her house for the second time. Larry, how do I find out Larry? Larry, I don't have a graph, so I can't use a graph. But I do have W of t, right? They do give me W of t. They say that's his velocity there. So how can I use velocity to find total distance traveled?
Integrate.
So yeah, so you're going to integrate from 0 to 12 W of t dt. Okay. So you just put that in the calculator, and what do you get?
Mm-hmm. 1.6.
Mm-hmm. That's what I got, 1.6 miles. So Karen lives closer to school. One traveled, if one only needs to go 1.4 miles to make it to school and the other needs to go 1.6 miles to make it to school, Karen is lives closer. But they both get to school. So my question is, who travels faster? Mm-hmm. Who rides their bike faster? It's not the question asked, but they could ask it. Whose rate is faster? How come? How do you know?
Because he's covering 1.6 miles within that time. But no.
Yeah.
Karen, it's not Karen.
It's Karen, right?
Yeah.
Because Larry goes 1.6 in 12 minutes, right? Karen goes 1.4 in how many minutes? 6 minutes, right? So her speed is a little faster. Didn't ask that question, but it could. It's always just something there. So yeah. Okay. Because don't assume that they travel the same speed. They don't. Okay. All right. Okay. So what I want you to do now is 5 and 6. I actually want you to start with number 6. Number 6. Start with number 6. It's the tank question. Water coming in, water draining out, water already there. Okay. So it's kind of like the beach question. It's similar to the beach question. Stuff coming in, stuff going out, stuff already there. Okay. Calculator question. I'll give you about 5-7 minutes to answer the question. If you finish, go to question number 5. If you don't, it's okay. Just go see what you can give up. So the wording on this one is what's important here. You got water coming in, you got water going out, and you got water that's already there. So at time 0, when we start, there's 150 liters of water already in the tank. Okay, and then at that moment, water begins to be pumped in the tank. A different pipe is draining the water from the tank starting at time 0. So the same thing. So at the same time, water's coming in, water's going out. Water is being pumped into the tank at a rate modeled by G of T. Okay. The total amount of water has been removed from the tank after the pump was turned on is modeled by P of T. What's the difference between, obviously one refers to the water going in, one refers to the water going out. But to answer this question, you have to know the difference between P and G. What's the difference between P and G, besides one going in and one going out?
G is a rate, but P is a total.
Exactly. They're both not rates. So it's not apples to apples with the question we did with total amount, right? When we did this question here with sand, both of them are rates, okay? When we wanted to find the total amount, we would use an integral, right? I don't have to do that with both of these. I only have to do that with the one that says a rate. So if I want to find total amount, if I want to find total amount at a certain time, removed, I would just use P of T. P of T, if I want to find, this is not a rate. This one is not a rate. If I want to find the rate going out of the tank, I would need to find the derivative of this. Okay? So these are not the same. They're not apples to apples. One is a rate, one is total amount. So if I want to find the total amount, what do I have to account for? What are the three things that I have to account for? If I want to find the total amount at a certain time of water in the tank, what are the three things that I need to account for?
The rate that's going in and the rate that the rate that the water's flowing in and the rate that the water's flowing out. I'm not entirely
No. What are the three things I need to account for when I'm trying to find the total amount of water in the tank at one time? There's three things I need to account for. What's three things I need to account for?
How much water they are using it.
Okay, so the initial amount. Okay, that's the first thing. What are the other two that I need to account for if I want to find the total amount of water in the tank at one time?
The total amount of water that is getting in.
So the total amount pumped in. So total amount pumped in into tank. What else?
And total removed.
Say it again.
And total removed from the tank.
Total removed from the tank, right? Total amount removed from the tank. Removed from tank. So what do? I add them all up, subtract them all, multiply them, divide them. What do I do with those three things? What do I do with those three things?
Add the first two and subtract the total amount.
Add the first two, right? Any water coming in or any water already there, I need to account for. But then I also need to subtract the water that's left, right? Because not all the water that gets pumped in or started there stays. Okay, that's our plan. We know the initial amount. I know the initial amount. It told me 150 milliliters. How do I figure out the total amount pumped into to the tank?
integrate G of T.
Integrate G of T, why?
Because G of T is a rate.
Okay, so I'm given a rate for pumped in, so I have to integrate that. So I have to integrate G of T from 0 to 11 to figure out that amount, minus, how do I find the total amount of the water removed from the tank. This is where it gets a little tricky.
Maybe we plug in 11 into the equation.
Yeah, we don't need to find the integral for P of t. P of t is already the integral. So all we got to do is plug in 11 for P. Okay? That's why I said the wording on this is very, very specific in terms of what you need to do. Every single problem that you will be given is something like this. Initial amount, total amount pumped in, total amount pumped out. That's all, every problem is going to be like this. Now, are you going to do exactly the same thing as we did here? No. But every single problem that you do will be like this. Every single problem. We just did one like that. Oop, not that one. This one right here, right? Total amount pumped in, total amount pumped out. How much was initially there at the beginning, right? It's the same thing. It's the same question every single time. So one of them is 150. So 150 plus the integral, and then you got to plug in for P of t. So you got to figure out the integral first from 0 to 11. So you go use your calculator. Math. Number 9 integral from 0 to 11. G of t. So G of t is -2. Use a negative, don't use a minus. Because if you use a minus, it'll give you an error. -2 parentheses times 1.21 to the t power plus 18. Plus 18. 123.084. 123.084. That's total amount pumped into the tank over the 11 minutes. Okay? P, and then the last one, we just plug in P, or 11 for P. So 0.89 to the 11 power times -154 plus 154. 111.262. Add the first, subtract the last, and you get your answer. $150 plus 123.084 plus, or sorry, minus 111.262. We get 161.822. It's total amount, so liters of water. Okay. That's how much is at time 11. At time 11, if I were to stop the clock and calculate, weigh how much water was in there, it'd be 161.82 liters. So from 0 to 11, which rate was faster? Pumping in or pumping out?
Pumping in.
How do you know? Yeah, pumping in. How do you know,
Because
Jugrush?
more rate.
Because what did it start with? 151, right? So if there's more than 151, that means more was being pumped, faster was being pumped in than pumped out, right? And that's what the case is, right? Okay, so the rate at which the water was coming in is faster than the rate going out. Okay. All right, so now I want you to do number 5. Number 5 asks you for an absolute maximum. Absolute maximum. We did one like that. So there's a reason why I have this one showing right now, because literally it's a word for word identical problem. The only difference is obviously context, but it's the same idea. Stuff coming in, stuff going out, stuff already there. And this one's a minimum question, but you're going to do it exactly the same way. Minimum, maximum, it's the same question. They want to know what was the total amount of sand on the beach. Total. This one wants to know what is the maximum amount of water in the tank? It's the same question, okay? It applies exactly the same. Just because it's a water tank instead of a beach, it doesn't matter. It's the same question, the same problem, okay? You have 5 liters already in the water tank. They give us a rate going in. They give us a rate going out. That's what we had for this guy right here. We had a rate going in, a rate coming out, right? So what did we do? Well, the first thing we did was found the first derivative for the total amount. Well, to find the first derivative, you need to find the total amount, which was part B. So we need to find y of t, which is the total amount of water in the tank at a given time. That's the first thing we need to do. Okay. So let's call that y of t. Since we called that y of t last time, let's call it y of t. So if we want to know how much water is in a tank, we have to take the initial amount, add the total amount pumped in, and subtract the total amount pumped out. Right? Sounds familiar, looks familiar. It's the same thing every time. We have to build that equation, though. We have to build that function. Okay. Well, we know the total amount. The total amount is 5 plus. How do we find the total amount pumped in? What do we need to do total amount pumped in?
Integrate.
Okay.
Integrate from 0 to t.
Good.
Which one was this? H of t?
All right. Good.
Subtract the integral.
Subtract the integral, right? So we don't need, you can do another integral, or you can just combine the integrals. G of t, right?
Yes.
dt. That's y of t, right? That's the equation to find the total amount at one time. Okay?
I'm sorry, I should have said
Z of t, yeah. Sorry, it's all right.
Oops.
I know what you meant. Okay. Okay. That's what we did for the problem earlier, right? This is called using your resources, using your notes. We did that, and then we had to find y prime. So that's what we got to do. Let's go find y prime. The derivative, well, 0, derivative of 5 is just 0. And then the derivative here is this, we use the second fundamental theorem, which just says both of these are just going to be h of t minus z of t. Okay. And then we have to find where those guys, so essentially where they equal 0, which is where they intersect, right? So that's what we're going to use our calculator for. We're going to figure out where they're going to intersect, where they're equal from 0 to 5, only from 0 to 5. Okay, so that's where we use the calculator. We go to the calculator. Clear anything out that's there because we don't need anything that's there. So h of t is -8 times 0.73 to the t power plus 13. Okay. Z of t is 4 times 1.3 to the power. Okay. We're going to go graph those. Zoom decimal. Well, they looks like they cross around -1, but we don't want negatives, right? We want positives. So if you want to see where they cross, zoom out a little bit. So go to zoom, zoom out. And there they cross right there. They cross right over here. That's what I want to figure out. So I asked the calculator to calculate something for me. Calculate where they intersect. First curve, second curve, best guess. Best guess is somewhere around there. It says they intersect when x equals, or when t is approximately 3.671. 3.671. It's the only place they cross from 0 to 5. They cross on the negative side, but we don't care about the negative side. Okay? That's our only critical value we're going to use. Okay? So then we got to make a table since they want to know absolute. They don't want to know if that's just a minimum or maximum. They want to know if that's the absolute minimum or maximum. Then we got to make a table to show the y values. Okay? So we're going to show the beginning, the critical value, and the end of the interval. We're going to calculate the y value, or y of t, for all three of those. Whichever one is the highest for maximum is going to be the answer. Okay? So y of t is right there. Well, I can tell you what, the first one's just going to be 5 because the area under the curve from 0 to 0 is 0. So the first one's going to be 5. Initially, there were only 5 liters. So it's just the battle between the last two. Oops, no. Okay. So since I have both of them in y equals, I'll show you the shortcut like I showed you that last time. I have h of t is y1, z of t is y2. So I want to go h minus z, so 1 minus 2, 1 minus 2. Okay. You don't have to use this shortcut, but it is a shortcut to use the calculator. Oops. Shoot, I don't want to do that. Oops, I have to put in h of t again. -8 parentheses 0.73 plus 13. Okay, so we have 5 plus the integral from 0 to 3.671. And then to do the shortcut, you're going to go to vars, and then you're going to go over to y vars, and then you're going to go to y1 minus y2. Again, you don't need this trick. It's just a little quicker. Dx. So that value will give me 10.612. 10.612. 0.612. So at time when time is equal to 3.671, that's how many liters are in the tank. Now let me do 5. And do the exact same thing. 5 plus integral (0 to 5 y1 minus y2). $8.488. So at the end of the interval, that's how much water is in the tank. Okay. We would say absolute max amount of water is 10.612 liters at t equals 3.671. Done. Okay. All of the questions are very similar. Sometimes they'll give you a table, or sometimes they'll give you an equation like h of t and z of t. Sometimes they'll give you a picture like they did on the last question we did, picture, graph. Sometimes they'll give you a table, right? They'll give you a table. Well, a table is just like a graph, okay? They're going to always give you one of those 3 things, and then they're going to ask you the same questions. They're always going to ask you the same questions. What is the total amount at one time? What is the maximum or minimum amount at one time? right? They'll always ask you the same question. So you're always going to need to do the same type of thing. It doesn't matter what type of question it is. Water into a tank, beach on the sand, that type of thing. Okay? Always very similar. More than likely, you need to use your calculator to calculate some of that stuff. Okay? All right, so tomorrow I'm going to give you the assignment.